Hi there. We're going to take a look at a test, Unit 3 test that we give over all the derivative rules. So hopefully some of these problems are going to help you as you're trying to figure out kind of where things went wrong or possibly how do we make sure that we get those right in the future. So looking at question number 1, we're asked for at x equals 3 whether this function, which is a piecewise, and we have all of these options. So let's see, it looks like my options are talking about continuity, being differentiable. So let's kind of work through continuity and differentiability here. So continuity, we first of all need to see if the function exists. So when x is 3, we would definitely use the second piece because of the equal to there. And so we would get 6 times 3 minus 9, which would be 9. Now, in order to be continuous, then we've got to have the limits on both sides as we approach 3 equal to each other. So the limit as we approach 3 from the left, we would use the top piece for that. And the limit as we would approach 3 from the right, we would use the second piece for that. Now do your substitution, you'll see that you get 9 and 9. That tells us that we are continuous. So right now, I know that A is not true. And I know C is not true. And I know E is not true. Because all three of those imply that the function doesn't exist. We showed that. And that the function is not continuous, which we just showed that. Now let's take the derivative to find out if we're differentiable. So we'll take the derivative of the pieces. The first piece, the derivative is 2x. And the second piece, the derivative would be 6. Now we need to see that when x is 3, from both sides of 3, do we get the same derivative? And so notice that when I plug in 3 to the first piece of the derivative, I get the same value when I plug in 3 from the second piece. That means that I am differentiable also. That means that answer choice D here is my answer. Okay, moving on. We're on question 2 now, and we're told a whole bunch of values, okay? So next, we want to then find, we're told if h is f of g of x, then what is h prime? So let's take the derivative. Going to have to use a chain rule. So I've got f prime of g of x, and I've got g prime of x. Now I want to know the value here when x is 1. So I'm going to substitute 1 in for x. And then I'm going to substitute the value. So g of 1, I look back through the information they gave me. G of 1, I'm told is 3. So I'm going to replace that with a 3. I'm also told g prime of 1 is negative 3. So I'll put that here. Then I'm looking for f prime of 3, which I was told was negative 5. So I end up with negative 5 times negative 3, which is 15. That's answer choice B here. Okay, let's keep going. With question number 3 here, we are asked to do the derivative. And for this one, we're going to have to use the chain rule. So look, you have something to the 4th power. So the derivative there would be 4 times that something to the 3rd power. Now that something is your 2x squared plus 1. And we got to multiply times the derivative of the inside. Now the derivative of 2x squared plus 1 would be 4x. I'm going to multiply the 4x and the 4 in front. And you can see then that that is answer choice E here. Okay, moving on to question number 4. This one was, it forced us to interpret the definition of the derivative. So look at this. We are trying to find which of these tells us the derivative of g of x when at the point 2 ln of 2. So I've got several definitions of the derivative to be using here. Okay, and I've got to see if we put those in the right spots. So my derivative, and I used f, but we're working with g of x. I know that I can have g of x plus h minus g of x over h. Now make the substitution. X plus h would, g of x plus h would be the ln of x plus h minus the ln of x all over h. However, we were told the value of x. So we are told that x is 2. So now we can make that substitution. We would have the limit as h approaches 0 of 2 plus h minus ln of 2 all over h, which is answer choice D. So, wow, that one was a lot of substitution, not a whole lot of calculus other than I had to know the formal definition and I had to make my substitutions appropriately. Okay, let's look at question 5 then. Write the equation of the tangent line to f of x at the point when x is 1. Now, I want you to see there's an answer choice you can go ahead and eliminate right off the bat. Did you catch it? Yeah, C cannot be the answer because it's not a line. So let's start with a tangent line. We're going to need a slope. To get a slope, we're going to have to take the derivative. So the derivative of negative 2x squared plus 2x plus 3 is negative 4x plus 2. Now we need the slope when x is 1. And so I get negative 4 times 1 plus 2, which would be negative 2. This is my slope. And immediately you can tell now that A is not the answer choice because A has a slope of negative 4. Now we need the point when x is 1. We have to plug this into the function. So I've got negative 2, 1 squared, plus 2 times 1, plus 3. So that's negative 2 plus 2, which is 0, plus 3. So I'm working with the point 1, 3. We'll go ahead and put that in the equation of a line. And then we're going to have to go ahead and simplify to try to fit it to one of the answer choices. So I'm going to distribute the negative 2. And I'm going to add the 3. So now let's see. I got to move things around to see if it can make it look like this. It looks like if I move the 2x back over here, yeah, I can make it look like D. So remember, sometimes you may end up with an equation that is technically right if it were free response, but can you manipulate it to look like one of the answer choices? That's going to be an important skill as we get closer to the AP exam. All right, moving along, we're almost halfway there. Number 6, we are looking for the derivative of the sine cubed of 4x. So we are taking a chain rule. We've got 3 chains going on here. We've got something cubed, then we've got sine of something, then we've got 4x. So we're going to take the derivative one step at a time. So the derivative of something cubed would be 3 times that something squared. Now I'm taking the derivative of sine, which would be cosine. And then I'm taking the derivative of 4x, which would be 4. 3 chains. I needed to make sure I got all of those. Let's multiply the 4 times the 3, which would be 12 sine squared of 4x, cosine of 4x. And that looks like answer choice D here. Okay, let's keep going with question number 7. Going to take the derivative of the ln. Now, this one is a tricky one because as it is, you would have to do a product rule. But if you'll do some simplifying before you do the calculus, it's going to make the calculus a lot easier. Let me show you what I mean by that. Remember that when you have logarithms, if you have multiplication inside of your logarithm, you can split that to addition. So this becomes ln of x plus the ln of the square root of x squared plus 1. You can go even further if we will rewrite that square root as a 1/2 power. Then we remember that exponents become coefficients of logarithms. Now, friends, I have not done any calculus up to this point. I've only simplified in hopes of making the calculus easier. Now I'm ready to take the derivative. Okay, the derivative of ln of x is 1 over x. Then I've got 1/2. Now the derivative of the ln of x squared plus 1 is a chain rule. So I've got 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x. Very nice for us that those 2's cancel out. And I'm left with 1 over x plus x over x squared plus 1. Now, look at your answer choices. None of them, except for the first one, is really two fractions being added. So it looks like we're going to need to make a common denominator. So think about what that common denominator would be. It would be x times x squared plus 1. Now, I'm going to have to multiply this first fraction by x squared plus 1. And the second fraction by x. And that leaves me with x squared plus 1 plus x squared, which you can see then will equal 2x squared plus 1, because you can combine those like terms. And that is how we get answer choice D for our derivative. I hope you're picking up on the fact of you get your answer and then you've got to fit it to these answer choices, right? That's part of the strategy with AP. You've got to be prepared for that. So let's keep going with number 8. Notice in this one, this is a second derivative. So we're taking the derivative and we're taking the derivative a second time. Let's do the derivative first, the first derivative, and we've got to use a quotient rule. So the quotient rule says low d high, the derivative of x plus 2 is 1, minus high, that's x plus 2, times d low, derivative of x minus 3 is 1, all over low squared. Clean it up just a bit by distributing that minus. It's going to make it a little bit simpler for us so that we get negative 5 over x minus 3 squared for our first derivative. Now, you might even go further and write that as negative 5x minus 3 to the negative 2. Now, let's do the second derivative. Chain rule. So you're going to bring the negative 2 in front to multiply by the negative 5. That gives you 10. X minus 3 to the negative third. And then be sure to write that back with a positive exponent by moving that x minus 3 to the third, to the negative third, down to the bottom. You can see how then none of these were the answer choice, right? And that's why you had to choose E. Tricky, tricky, tricky. All right. Now, my second one, I'm sorry, number 9. I see product rule going on. I don't really want to do product rule, so I'm going to simplify before I do the product rule. That just means I'm going to be distributing this x to the 1/2 to both of those terms before I take the derivative. So that gives me x to the 5/2. Think about it, friends. You've got x to the 1/2 times x to the 4/2. When you multiply, we add exponents. So that's x to the 1/2 plus 4/2. That's how I got x to the 5 halves. Minus 3x to the 3 halves. Again, think x to the 1 half times x to the 2 halves. That gives you x to the 3 halves when you add those exponents. Now, let's take our derivative. That becomes 5 halves x to the 3 halves minus 9 halves x to the 1 half. Okay, we can make a common denominator here. It looks like they have a half in common, and they also have an x to the 1 half in common. So that becomes 5x minus 9. Tricky. I don't see any of my problems. The only one that looks close to it is this b here. Let's see if I can make them look like the same. Okay, this would be 1 half x to the negative 1 half distributed to 5x squared minus 9x. Let's see if we can get them to look the same. It's the only one that's close, right? Because of the 5s and the 9s. So what I'm doing is I'm taking an answer choice now and I'm manipulating it to see if they're the same. I'm going to distribute these two here. It'll give me 5 halves x to the 3 halves. That'll give me 9 halves x to the 1 half. Look, friends, these two are exactly the same. That's why answer choice B is the answer. But tricky because I had to manipulate, I had to get my answer. Then I had to take an answer choice that looked close, had to manipulate to see if I could get them to be exactly the same. Really beefing up those algebra skills. Okay, 3 questions to go. We've got number 10 here. I'm probably going to use a similar approach to this one. So I'm going to bring this x, the square root of x, I'm going to bring it to the top as an x to the negative 1 half. You're going to find that I tend to simplify the function before I take the derivative just to make it easier. Now I've got x to the 3 halves. We talked about that in the previous problem. And I've got minus 4x to the 1 half. Now let's take our derivative. I've got 3 halves x to the 1 half minus, I've got minus 4 times a half, so minus 2x to the negative 1 half. Okay, now I'm going to have to get really creative. Nope, look here. It's looking pretty close. Can I make it look like A? Yeah, that just needs to come to the denominator. So friends, once I take my derivative, I'm taking a peek at the answer choices, right? To see what I've got to make it look like. Otherwise, I probably would have gone and made a common denominator and yada, and that really wasn't even what's necessary for this problem. So take a peek at those answer choices, see what you need to make it look like to help save some time here. Okay, question 11 was a lot about looking at this graph and seeing what we can tell if any of these are true. Okay, number 1, Roman numeral 1 says the derivative is 0 when x is 3. So look at when x is 3, we had a cusp there. So the derivative is not 0 there. The derivative is undefined there. So I know 1's not true. That means D and E cannot be my answer choice. Look at number 2. Number 2 says the derivative at 2.5 is less than 0, so it's negative. Look at 2.5. The function is increasing, so is the derivative negative? Nope. 2 doesn't work. That means that A's out, B's out. I'm only really trying to see if 3 is true. It says on the interval negative 4 to 5, from here to here, there are 3 values where the function is not differentiable. I've got 1 because I've got a hole, not continuous. I've got a second place here because it's not continuous. There's a jump discontinuity. And then finally, I've got a third spot there because of the cusp. And so C has to be the only one that is true. I don't know about you, but I like those questions, and I don't like them. I like them because there's no real math to do, right? Just analysis. But man, I have to be really, really careful that I'm watching for all the details that might slip me up in those kinds of problems. All right, we got one left to go. Let me zoom out just a little bit so my document camera doesn't go totally crazy on me. There we go. All right, question number 12. It says, here's the line. That's a normal line. Here's the equation of a normal line at the point 1,4. What's the value of the derivative? Now, you're going to have to remember the normal line is perpendicular to the tangent. The derivative tells us the slope of the tangent. So if this is the normal line, let's find its slope first. I can move the x over, and I can divide by 7 on everything. So I know the slope of the normal line is negative 1/7. That means the slope of the tangent line has to be the opposite reciprocal, which means it has to now be positive, and I have to flip that fraction. So that means that the slope of the tangent is 7. And that is exactly what the derivative tells us. So this problem must be answer D there. So friends, I hope this helps you with the problems from this part of the test. Really working through the derivative rules. Let me know in the comments below if you still have some questions. I'd be glad to answer those. Bye for now.